So this is the robot without any sort of position holding. It's a straight back stick, which is just given a full reverse command. And then right here, I'm giving it a full forward command. Each motor is getting 100% power. Right now, I'm going to try to turn it to get it a good alignment back up the driveway. I'm going to engage the heading hold function, and as it comes up, you'll notice that it's making small oscillations to correct itself. And as an example of what the heading hold can do is any external stimulus like kicking it will just cause the robot to correct itself. And let's pick up the controller before it trips itself. And this is just to prove that I'm not giving it any sort of input. The controller's sitting on the robot. And clicking that right button will disengage the heading hold, and then I'll give it a good kick. And it just kind of goes wherever it goes. You can see it's starting to roll down my driveway. So what I'm going to do is re-engage the heading hold and let it roll down a little bit, and you'll be able to see how it still maintains its heading even though it's heading downslope at an angle. If you're wondering how this is all put together and made, basically there is a U-shaped 11 gauge steel box sheet metal frame. It bolts to the original chassis. I have a few pieces of rectangular steel tubing that elevate the computer box and the blade motor. The motors themselves are from China. These are 350 watt scooter motors that come off of Razor brand scooters. Size 410 chain goes to 3/4 inch stainless steel axle that goes to not golf carts, but go-karts. These are just standard pillow bearings, 2 tall ones, and those over there. These tires are also, they're from the go-kart supply store, but you would find these on small wheelbarrows. It's a keyed shaft with just hex screws that hold that all together. The mower itself is a Fiskars brand reel mower. I believe it's 5-blade. All I did was I unbolted the old tires. The tires didn't caster, they just rotated on one axle. A more 11 gauge steel, I believe that's 3/4 inch angle iron, and some casters that are getting beat up. Those are $8 or $9. It cost more than they're worth. This is an XLR connector. This is how I charge it. I use a 24 volt charger that goes to a wheelchair, electric wheelchair. These are just 60 millimeter PC fans. I got a bunch of them for $1 or $2, and a big pack of grates for safety. Chinese switch, Chinese ammeter, Chinese safety stop. This switch triggers the power for all the electronics. This one does the power direct to the motors, so I can still run the electronics, check out my battery voltage with no risk of this thing just spontaneously spinning in circles. And I guess right now we're at 0.9 amps, and that's only the electronics and the fans running. As far as the electronics go, this thing is based off of an Arduino. Most of the pieces you see in here are not American made. This is a SaneSoft Arduino USB shield sitting on top of an Arduino. Those are both Chinese knockoffs, all powered by a barrel pin adapter. Got like 10 of those for $1 from China. Those all run back down to a terminal block from China, an ammeter from China, a voltage, I guess it'd be they're called buck converters. Takes it from 24 volts down to the 12 volts that the Arduino uses. This is what drives the motors. That's a motor controller. That's from the UK, a company called Piborg. Mostly makes their products geared towards the Raspberry Pi. but they did release some libraries for the Arduino, so that's what I'm using it there. This is all over I2C connection, and then I just piggyback my gyro off of that I2C line. The gyro, this is what makes the heading hold all possible. This is an absolute position sensor. Let's see if I can stabilize this. It gives me 9 degrees of freedom. It takes all the filtering algorithms, puts it all into one board, and it just gives me an exact heading, both XYZ axis as well as accelerometer data and rotational data. What I do with that is every 10 milliseconds, about 100 times a second, the Arduino here checks that sensor, finds the position that the robot is currently facing as far as angle wise, and it compares it with what the angle should be. The angle is set by the controller, so if I hold left stick, it starts decreasing the angle that the robot needs to hold. It cross-references with the sensor, gets a difference, and then the Arduino applies a PID algorithm to determine how fast and how accurately to correct, and that's only in the heading hold. Otherwise, if you're not in heading hold, it's just straight input. Left stick puts this thing into 100% left turn. Left forward stick gives it 100% forward. And that's about it. That's all there is to it.